question number 91. Question is easy if the concept is clear. Okay. If a radiation of energy 5.25 electron volt falls on a metal surface. Okay. This is the energy which is given 5.25 and this energy is given in electron volt, not in joule. Okay. Then the maximum kinetic energy of the ejected electron will be, work function of the metal is 3.25 eV. Okay. The answer is given in joule. It means whatever the value we will get, we have to change it into joule. And photoelectric effect, total energy is work function plus kinetic energy of the electron, and you need to just find out this kinetic energy. Clear? If a radiation of energy falls on the metal surface, then maximum kinetic energy of the ejected electron. Okay, so kinetic energy would be equal to h nu minus h nu naught, and this h nu is clearly given in the question that the total radiation that you are providing is 5.25 eV minus work function of the metal is also given 3.25 eV. So this will be 2 electron volt. Final answer, but the answer should be there in the joule. Change this in the joule value. Okay, so 1 electron volt is 1.6 into 10 to the power minus 19 joule. Okay, so I'm just going to multiply that value, this, and if you solve this, then you will find this is 3.2 into 10 raised to the power minus 19 joule. Clear? And very simple calculations were there. If you know the concept, those calculations you can do and right answer you can choose. Take the question number 92 now. If all the given molecules are moving with the same velocity, then the molecules whose wavelength will be maximum is, wavelength you are talking, lambda value. Recall the de Broglie expression, isn't it? Now in this expression, if you just look at h is constant, they are talking about velocity which is also constant as per the question that all the molecules are moving with the same velocity. So only one thing is determining here. Lambda would be proportional to, even inversely proportional to the mass. So more the mass, less would be the lambda value. Clear? Okay. So you have to just check the molar masses of the given gases. I'm talking about O2. So what would be the molar mass? 32 gram per mole. For CH4, 12 plus 4, once again 16 gram per mole. Helium it is 4 gram per mole. Nitrogen, 28 gram per mole. You have to find out the molecule whose wavelength will be maximum. Maximum wavelength is associated with minimum molar mass, helium. No doubt there are. So the correct answer you can easily choose. Yes, the right answer is clearly given in option 3. Take question number 93. Correct order of the wavelength of the given radiations is. So we have various radiations given here, and if you know this order, you can easily choose the right answer. Right. So among these given order, if you just look at the option 2, you will find that first we have the highest energy associated with the radio waves, then microwaves, then IR, then UV rays. Then turn for UV rays comes because we are aligning them in the order of wavelength, right? So least wavelength is associated with the UV rays and the maximum with radio wave among the given radiations, right? So second is your right answer. Question number 94 I have here. How many grams of concentrated nitric acid solution should be used to prepare 200 ml of 4 molar HNO3? Concentrated HNO3 is 70% pure, right? So basically in this question, two things you need to do. First, with the help of molarity and the volume, find out the moles. With the help of mole, find out the mass. Then check it's not pure. You have to find out that amount in which that particular mass is present. So let's move step by step. First of all, I have molarity. Everybody know that molarity is moles of solute upon volume of solution, right? So I'm just going to keep the values here. For molarity, it is 4 molar, right? And this is equal to the number of moles of HNO3 divided by the volume taken, right? So volume is 200 ml, but volume should be in liter. So that's why 1000 I am multiplying here. Clear? Moles of HNO3 I can easily calculate. So moles of HNO3 would be 4 into 200 divided by 1000. Okay? So 0.8 mole these are. Now simultaneously, if someone asks me to find out the weight of the HNO3, so moles is equals to given mass by molar mass of the substance, right? So what would be the weight of HNO3? With the same expression I'm going to take. So weight of the HNO3 would be number of moles, those we calculated, 0.8 into molar mass of HNO3. HNO3, 1 plus 14 plus 16 into 3. So that would be 63. Clear? Just solve this. So if you just multiply the mass you are going to get, that would be 50.4 gram if I just multiply these two. This is the mass of HNO3. Now the question is not up to here because the solution is 70%. It means if as it is 70%. What 70%? HNO3. So here you can simply say that 70 gram amount is present in its total 100 gram sample, right? So now you want not 70 gram, you want 50.4 gram of HNO3. And how much amount you need to take from the sample? So 100 by 70 into 50.4, right? So to solve this, simple. Your turn to calculate final answer. Yes, if you solve this, you will find this answer comes out to be 72 gram. So the amount that actually you need to take is 72 gram, and yes, this answer is given here in option 2. Now in the continuation, turn for the question number 95, and this is once again the question of statements. Two statements you have, and on the basis of this you need to just choose which one is correct, which one is not, or both are correct, right? Law of definite proportion states that a given compound always contains exactly the same proportion of the elements by weight. Whatever be the source of that compound, definitely the proportion of elements should remain same. And yes, the statement 1 is correct. Second statement says mass percentage of the copper in copper carbonate is 44.5%. So here you need to calculate a bit. How? So if you know that atomic mass of copper, this given in the question itself, 63.5 U, right? So let's calculate the percentage. This would be 63.5. This is the amount of the copper in this compound, CuCO3 that we are taking, divided by 63.5 plus 12 for carbon, because carbonate we are taking, and 16 into, how much I need to multiply? 3. Done? Solve this. And I need to multiply 100 as well, because percentage we are calculating, right? So this comes out to be 63.5 divided by 123.5 into 100, and this percentage is nearly more than 50%. It is 51.4%. It's not 44.5%. And if it is so, it means the second statement is wrong. And on the basis of this, the right answer you can choose. It is clearly given in statement 2, in option 2, that statement 1 is correct, but the statement 2 is incorrect. Okay.